So for water molecule, the net dipole moment, it will be equal to 1.84 dBi. So for that we have to go through the geometry of water molecule, and also the geometry of water molecule, it will be like this: oxygen, then 2 hydrogens, it will be like this, isn't it? And also the dipole moment, it will be acting through this vectors. Okay, so here this water molecule, it has got a V shape or a bent geometry, isn't it? Water molecule has got a bent geometry, and that is why, see, these OH bonds, they are polar, and again 2 OH bonds are there. It will not be cancelled by each other since it has not a since it does not have a linear geometry. So here for OH bonds, what happens, the 2 vectors are in this direction, the magnitude of this dipole moment, it will be in this direction, so it gets added up, and therefore it will be having 1.84 dBi units. Okay, then some more examples are, so for carbon dioxide, it has got dipole moment 0. Then for CS2 also, the molecule, it will be having dipole moment 0, since it has got a linear geometry. So both these are having linear geometries, so the dipole moment will be 0. Then for BH3 means the geometry of that particular molecule, it will be like this: BHH. Okay, that means it has got a triangular planar geometry or trigonal planar geometry. So what happens here also, the BH bonds, the dipole moment of each BH bonds will be cancelled by the other. Okay, so what happens is, therefore the dipole moments of these molecules will be 0. For these molecules, dipole moment will be 0. So this is based on the geometry. This explanation, it is based on the geometry of the molecules. Then one more example, that is ammonia molecule. See, what about the geometry of ammonia molecule? We have seen in our previous chapter, isn't it? That is NHH, isn't it? NH3 molecule, and the geometry, this is a lone pair of electron, it will be like this. So the geometry of the molecule, it will be a pyramidal geometry. That means it will be like this, isn't it?